celebrating today. As all of you are aware, Indian Society of Remote Sensing celebrates this day as National Remote Sensing Day. And this year also, we are having this program where we have invited a very eminent scientist from our country, Dr. Rajkumar, who has been former director of National Remote Sensing Center at Hyderabad and also former president of Indian Society of Geomatics. And currently he is a professor at research professor at Space Application Center. As all of you are aware, Indian Society of Remote Sensing is a professional society which has more than 5,000 members all across India, and we do large amount of activities in terms of promotion of remote sensing, geospatial technologies, along with academia as well as industrial members. And in context today, when remote sensing and geospatial technology has been given emphasis by Government of India by opening this sector for private participation, remote sensing technologies are gaining large amount of momentum in solving day-to-day problems for common man in this country. So at this occasion, without taking much time, I welcome Dr. Rajkumar, and I also thank him for readily agreeing to give this talk on a very important topic. As I was telling that we are on a threshold of, new emergence of the way we do remote sensing and geospatial things in India. So his topic is also very apt. It is emerging trends on Earth observation in Indian context, and he will be focusing in particular to the upcoming NASA ISRO synthetic aperture radar mission. This mission is also a testimony of our growing influence at global scale, where two major space agencies, NASA and ISRO, has come together, and they are now jointly built a synthetic aperture radar operating in two frequencies, L and S bands are. The satellite is getting integrated at URRAV Satellite Center in Bangalore, and most likely it is supposed to be launched somewhere in the first half of 2024. So with these words, I welcome you, Dr. Rajkumar, and we look forward for a wonderful talk on this occasion of Remote Sensing Day. Thank you very much.
Thank you, sir, for giving the appraisal about the Indian Society of Remote Sensing and also highlighting the role of Dr. Sarabhai and also introducing our esteemed speaker to our members. So just to continue with Dr. Ka's introduction, I will just add few lines about Dr. Sarabhai. Dr. Sarabhai is also known as the father of the Indian Space Program. He founded a physical research laboratory in 1947 at his residence retreat for the research in the cosmic rays. And then later on, he has played a pivotal role in setting up many institutes in India, and more importantly, the founding of Indian Space Research Organization. As we all know that Chandrayaan 3 is going to be reaching moon soon. So International Astronomical Union in 1973, they have named as a crater in Sea of Serenity in the moon as the Vikram Sarabhai crater. And our for this one of the first missions of on moon, Chandrayaan 1. So they had this moon impact probe, and Chandrayaan 2 had a lander known as the Vikram. So these are some of the highlights of Dr. Sarabhai. And now I will briefly read the bio data of our esteemed speaker, Dr. Rajkumarji, for the benefit of our members. Dr. Rajkumar, he completed his PhD from Lucknow University in physics, and he is the science lead of the NASA ISRO project, that is NISR, and he has been in the various committees like alternate principal on the Committee of Earth Observation of Observation Satellites, that is COS, Chairman Committee Atmospheric Application and Research MOES of ISRO, Program Director of Marine and Oceanography Group, and the ISRO's ocean and meteorology related satellites like MOP program, OceanSat 3, SCATSat 1. So he has been the project director of these projects. And he has also served as a director of National Remote Sensing Center, Hyderabad ISRO. and previously he held various positions in the space application sector. And for his contributions to the Indian Revolution, he has been awarded with various awards, namely Satish Dhawan Award in 2017 for his contributions in the remote sensing, and Hariom Preshit Vikram Sarabhai Award for 2008, ISRS PR Pisharoti Memorial Award for 2006, and many more. So, with few this introduction, I request Dr. Rajkumar ji to start his today's lecture on emerging trends of Earth observation in Indian context, with focus on NISA. Sir.
Actually, Praveen, just check whether on YouTube still. I think there is some issue. Just find out whether it is
Let
going.
me see. Priyanka, you are able to see the YouTube?
Yes, sir.
It is coming live.
Yes, sir, but it's lagging because of internet. So, like the team is fixing all that.
It is live now.
Yes, sir, it is live.
Okay. Okay, sir.
Yes, sir. Yes, sir. We can start.
Hello. Yeah. Thank you, Dr. Prakash and Dr. Praveen Thakur for the invitation to give this lecture on this very, very important day on the birth centenary of Dr. Vikram Sarabhai, 74th birthday of Dr. Vikram Sarabhai. This is very, very important day, as we say, in the for the remote sensing as well as a space science person. Not only with space science, I can say this is for the whole country's science because he has contributed not only for the space science but many other fields also. So I just take you. You are able to see my slides, isn't it? Just for confirmation.
Sir, one blank slide is visible.
Blank one. Yeah, that's what I was. This now.
Green, white with that white background.
White only, white. That's what I was seeing. White.
Presentation is not coming.
Yeah, that's what I'm seeing. White is not coming.
Yeah, share full screen, sir. Entire screen.
Yeah, I'm screen full screen only. That's why. Share content screen. Entire screen only. Now.
Yes, now open the presentation. Yes, sir.
Yeah.
Yes, sir. Now full screen, sir. Just.
Yeah. Sorry. Yeah.
Yes, sir. Yes, sir.
Yeah. Yeah. So sorry for the this small hiccup. So on this very important occasion on the birthday of Dr. Vikram Sarabhai, I'll just, as Dr. Prakash told, just talking about that mostly on the emerging trend in Earth observation. That means what are the present we had satellites or missions from the Indian point of view, as well as mostly focusing on the afterwards on the NISR, which will be more detail I will be talking about. But before that, because this is the very important occasion, so as all of us know, most of us know, I can say, this is the genesis for the space program in India. And these are the words which by Dr. Vikram Sarabhai, this is the golden words, what we say. If we really want to have meaningful role, then we have to be second to none. And that's when we started 60s. We had a very small setup, we can say, starting with the communication side. And then all these pictures you might have seen, the bullock carts and all those things that time. And then now you know. But you see the present scenario, as everyone knows now. This is a hot topic these days. So from that days, we have come up to this stage. I can say we are reaching to the moon. We are landing on the moon a few days from now. And these are some of the, you see the images taken by our own Chandrayaan 3 for this of the moon, which will be just touching also in the on the next, I can say, week or so. So this way we have our program has reached not only this. This is the another satellite we are reaching. This is the natural satellite we are reaching through our uh, uh, all other satellites what we are launching. But if you see the overall evolution of the Indian Earth observations, starting with the experimental satellites Bhaskara 1, this was the very, very small satellite Bhaskara 1 and 2 in the 1980s. We started from those satellites, and then we reached the operationalization of the remote sensing through the remote sensing program, where the Indian remote sensing satellites started from ISRS 1A, 1B, 1C, and then go on. These are the different satellites, optical range. We have many satellites, and then we started imaging. Those are the not very high resolution, I can say. There's a 25-meter, 50-meter type of satellite imaging we had. But in the 90s, we started with the three-tier imaging. That means with the coarser resolution, higher resolution, as well as very high resolution satellite, like we are going or with the Cartosat series, which is the sub-meter resolution images are being provided.
Hello.
And
Sir?
not only sharing, I think.
No, it is shared, sir. It is shared. You can start.
Okay. So yeah. So I just on the I think previous was you were audible, but now we're not in between this audio went. So I was talking about this evolution of the Indian Earth observation satellites, starting from the Bhaskara 1 and 2, which was the experimental satellite, I can say, but these also worked. Radiometer were there very well. It worked for some time, and then we went to the operationalization of the remote sensing satellite, starting from the optical sensors. From the ISRS series, which is called the Indian Remote Sensing Satellite Series, from the 1A, 1B, 1C, etc. With the somewhat in the terms of today, if we say they were the not very high resolution, they're 25-meter, 30-meter resolution. And but later on in the 90s, we started with the three-tier imaging, what we call it, with the coarser resolution, higher resolution, as well as a very high resolution type of satellites. And you might have seen many images from the Cartosat type of satellites, which is giving the resolution of the pictures. I can say with the sub-meter resolution, 30 centimeter resolution pictures, very high resolution satellites. And in between also not only the two-dimension but third dimension also, that means stereo imaging from the Carto 1 satellite, where we get the very high resolution distal elevation model also. So these were the era when we started the high resolution images, as well as for the societal benefits for the mainly from the Indian context, but not only from India, but all other the regions of the globe also. We started giving the data, and then people were using this data and still utilizing it. Thereafter, we started the series of the satellites for the Earth observation, not only Earth observation, but atmosphere and ocean sciences also. Where you know the series where daily pictures were coming earlier also on the TVs in the night. People were seeing the images for the inset for the weather satellites, and which is now very common through when the mobile and all this internet came. Then people can see every now and then this data, images, as well as not only the data, but these are the very helpful in predictions. That is the predictions of the weather for the next few days using this images, as well as the models, and for ocean satellites also, which is the OceanSat 1. I started with OceanSat 1 in 1999, then OceanSat 2, OceanSat 3 is presently it is there. I will just dwell upon these also. But all those things, what I was talking about, this as I started by Dr. Vikram Sarabhai, all the societal applications started from the tele-education, telemedicine, navigation, as well as from the planning of the societal benefits of the infrastructure planning for the urban zone, as well as the coastal zone, all and all the natural resources point of view. All these things are being done using the Indian Earth observation missions, which I talked about starting from the ISRS series. If it, mostly there are two types of satellites are there in the observation point of view. One is optical, we say, where the visible as well as infrared are there. And then they started from the earlier the 1980s, where you can see we have the series of ISRS 1A, 1B, which is the special resolution of the around 25 meter, 30 meter, as well as the with the overall coverage, I can say around hundreds of kilometers. And then you see when the time is reached up to the Cartosat series, which is a very high resolution as I was talking about. But in this case, when we go very high resolution, you cannot have the very large swath. So this will take only the location. So these are the optical series of satellites are there not only for the Earth observation, as I told, for the weather also. In microwave series, where we have the not the directly picture what we see from the optical satellites, but we have many other information as well as usefulness in the day and night time, as well as the different type of weather conditions, like low rain conditions. We can get the pictures as well as the information. So these are the different type of sensors, what we call it radiometer, which is a passive sensor. I will not go much on these things, but radiometers of the sensors are there, which were starting from Bhaskara, as I told. And then we had the OceanSat 1, where the multi-channel scanning radiometer was there. With the CNES France, we had the collaboration with the megatropic satellite in the tropical region, 2011. And recently, last year, we had the experimental satellite. This is the humidity sounder mini satellite that is presently working. And then another type of sensors are the spectrometer sensors, which we started in the 2009, mainly for the global wind vector point of view. Then we have SCATSat 1, 2016, and now we have last year we launched OceanSat 3, and we'll be having the OceanSat 3A also in a near future. Then we have the airborne sensor for the mainly started from the disaster point of view, disaster mapping, synthetic aperture radar, that is a side-looking radar, airborne radar in the 90s, and then few years back we have the airborne SAR, which main focus I will talking about the NASA ISRO synthetic aperture radar. So for that purpose, we've had our airborne sensor itself, which we launched. We had the data over India as well as the sites over the US also. This data I still have talking about that also. And then spaceborne synthetic aperture radar, which gives the very high resolution images. In the C band, we have RSAT 1. You might have heard about that, RSAT 1. Then we have RSAT 1A last year itself series, and then NISA. So overall, if you see, these are the presently orbiting sensors from the optical, microwave. All these sensors are presently there. And some of the this will be coming in the near future, like NISR as well as the INSAT 3DS, because presently INSAT 3D, 3D these are the missions on the geostationary orbit. All others are what we talking about. Mostly remote sensing are there from the polar orbiting, but these are the from the geostationary sensor from the weather satellite point of view. INSAT 3D is there, 3DR is there, and we'll be having INSAT 3DS this year itself. So these are the overall present sensors, and regarding these sensors, when we are talking about ES04, that is a synthetic aperture radar, what we call it the RISAT, micro sensor synthetic aperture radar. So this was launched last year February itself, and then we had the ES06, which is the nothing but the OceanSat series, what we call it earlier. We used to call it OceanSat series. Which have the different sensor ocean color monitor, which is very useful from the fishery point of view, and many other ocean parameters. Then we have a scatterometer sensor in that KU band scatterometer, and we had the sea surface temperature monitor sensor also, which unfortunately which is not working presently. So I'll just showing some of the data of this, how it is being used. This is the data from the sensor. We can see very agriculture point of this is the most useful sensor from the agriculture point of view. It is being used by agriculture ministry from the different, because in the time of the rainy season, you can't get data from the optical sensor. So this sensor is quite useful. So these are some of the images or the data classified data. It means classification you do with high accuracy for different regions, for the paddy, jute, as well as bajra. These are different crops. So these are just example of that. And in addition to this, there are many applications. Like one of the major applications in the case of flooding time, because that time you can't have the optical sensor. So this is one of the image you see prior to flood and after flooding in the Delhi region. This is from the NRC side. This is the images from the. They are providing the images from this Bhunidhi, which is the major source for giving all this remote sensing data from NRC. In addition to that, we had the high resolution soil moisture. This is very important from the many applications from the land application. We call that also we have started providing this. And some of the ocean applications, in addition to all these terrestrial applications, these internal ways very useful from the point of view of many applications. And oil spill, this large scale oil spill can be detected using this sensor. In addition to that, there are many others. This is the soil moisture again for the, if it is a time series, if you know from this sensor, because it's repeats 17 days repeats. So you can get the different time period or time evolution of the soil moisture, which can be used for many applications. There are one more one of the major applications using the interferometry of the synthetic radar. You can get the like earthquake, not I can say exactly prediction, but evolution of this or the subsidence measurement you can have. This is one picture showing that evolution of the Mauna Loa volcano, where we using this data from the 2 dates, we can get how this lava is flowing and what is the how the surface is changing. So this is the one of the example, and this also is useful for the from the high resolution winds, as well as the, in addition to ocean and other applications, high resolution winds also in the case of cyclone region, which can be assimilated in the numerical models for the better forecast or the structure of the cyclone. Then as a sensor I was talking about, this is the OceanSat 3 series ES06, having 3 payloads as I told, which gives a number of parameters from the ocean color point of view, because it has a ocean color monitor, 13-channel ocean color monitor, as well as the spectrometer, which is the for the ocean surface winds and other applications. So there are many applications from the ocean point of view. In addition to ocean, there are atmospheric and land applications. They are also there. And one of the things which is not normally possible from other sensors, the cryosphere from the, if you go to polar regions, uh, then sea ice application, melting of the sea ice, as well as the different type of sea ice extent. All those things also are possible using, because this sensor has a 2-day repeativity. That means every 2 days it comes up the same location. So using that, we can or because it has different challenges, because all these have different resolution, different swath, different timing. So but now with the different new technologies, we can have this type of synergy of the different sensors. And then anyhow, AI ML is the approach now, which is being used in all the fields, not the remote sensing, but many other fields also, and highly useful field, and very challenging also, I can say, because it has to be taken with the caution. This data AI ML data, because different types of data are there, and then how to use it, that is also ingenuity of the person is also required in that. Anyhow, so those are the different future sensor, and this sensor I was talking about earlier, which is the sensor swath altimeter, what you call it, because altimeter, as I told, it was a very narrow swath, but this is a SWOT sensor, we call it, surface water ocean topography mission, from the French and US. This is launched in December only, and this gives not only the data over the ocean, not only the coastal region as the open ocean, but also on the for the hydrology point of view, very important sensor. And this is the, because we are part in the science team of this, so data is you can see in the one day very less data will be there, but more than many earlier altimeters. But in around 20 days, you get the lot of data for the coverage point of view. And if you see, these are the top side, we see there are some simulations we did earlier, like other altimeter like JSON or synthetic or Saral Altica altimeters, like that sensor. If you have that, if you see the left hand side, you get the very few data sets. But if you combine two sensors, you will have some data. But like SWOT type of sensors are there, is there, we can get a lot of data and very high resolution. So for the not only the ocean and that from hydrology point of view, and the bottom channel, you see these are the test data, initial data is being provided to the science team, where we can see in the middle, this is the actual data from the SWOT, and this is the right hand side, you see the simulated data from the other present satellite. So you can see this coarser resolution from the other satellite, but from this sensor we are getting the very good data. And another sensor is coming, which is called the Krishna, the thermal infrared imaging satellite for high resolution natural resources. This is again an Indo-French collaboration. This will be coming in around 27-28. Very useful for the ecosystem point of view, as well as the coastal regions, because this will be having a high thermal sensor will be there, that is in the near infrared range, as well as thermal infrared radiometer. So this sensor will be coming in the few years, and resolution wise, if you see, earlier we were talking about a kilometer, but this is around 50-meter resolutions will be their data in the terrestrial point of view, and the ocean, it is 1 kilometer data will be there. But now we are talking about this focusing on the sensor, which is NASA ISRO synthetic radar, which is a new concept, I can say. It is there on the from the sensor point of view in the synthetic radar, because the synthetic radar, normally what we are having is the sensor which is very if you go for the high resolution point of view, then we get the very less swath, that means the area coverage will be very less. But if you go for the somewhat coarser resolution, that is 50 meter or 100 meter, then you get the swath of the around 200 or 300 kilometers. So that was the mostly in the conventional synthetic radar, it is there, and this is just a small video showing the simulations, how this satellite will be launched from the India, from the our own GSLV in next year, early next year, and afterwards within 10 days this will be satellite will be started operating after all this engineering checks. Because one of the most challenging, which is not you're seeing in the your screen, how this antenna, because normal antennas are the array antennas in the normal synthetic radar, but this is the unfurlable 12-meter antenna. You can simply assume that 12-meter antenna in the space, how it will be opened up and how it will be working. So that itself is a challenge, I say. So when this start working, then we'll start getting the data from this beautiful sensor, I will say, NASA Synthetic Aperture Radar. So how it started, just a brief, because NASA has their decadal survey. They wanted a sensor for the deformation point of view, that a very high resolution subsidence or the changes in the earth, that is from the point of view of the landslide or the earthquake and all other type of deformation sensor, as well as from point of view of the ecosystem structure, and to see the changes in the ice in the regions in the Himalaya, as well as other regions, but not only in this region, but from the polar point of view also they want to study. So they came up with this one concept of the sensor, and then when we got discussed with India, then we decided that we'll have a joint synthetic radar, not only L band, because earlier they were thinking only one single band. Then we have L band from their side and S band from other side. So this is now the collaboration that point of view. Sensor is both we are having sensors, as well as the spacecraft is from the India, as well as launch from India. So this cooperation is going on since many years. The main reason of this satellite, as I told, to understand the response of the ice sheets as well as glacier in the from the climate change point of view. That is the overall cryosphere, I can say, and dynamics of carbon storage and in the vegetation agriculture point of view and the forest point of view, what is the carbon storage is there and how they are changing. And the third is the very important, as I told, from the point of view earthquake, volcanic eruption, as well as the subsidence in the land region. So this sensor started from that point of view, and this will be the few important features. Just I wanted to say, this will having L band data, S band, and L plus S also. Many places you will have only L band data. I'll coming upon that. Some places you have the only S band data, that mostly the regions around India and the polar regions. And some of the regions will have the data from the both the two frequency. That is a very for the many applications, two frequency data, many polarizations data, and the interferometry also. All this point of view, this is a very good sensor. And the technology, I will be just briefing about SweepSAR technology. That is the by which how you get the high resolution as well as the higher coverage also. And this will have full pole data also, full pole also, single pole, dual pole data also, and repeat pass interferometry. So these are some of the very unique features of this. And important, one of the most important, I can say, with the 12-day repeatability, is that data will be open and freely available to everybody. Whoever want to use, they can start using the data. That will the one of the major things. So these are some of the characteristics. As L band is around 1 gigahertz, that is from the US side, JPL, and from S band from the ISRO side, Space Application Center. This sensors have been developed, instruments have been tested, and they have gone to the all this testing and integration in the US lab. And from there it has come now, as Dr. Prakash was telling in the beginning itself. They're now in our own URSC center in Bangalore. There are an integration and testing, and almost last stage of testing it is there. And very soon, next year beginning itself, we are planning to launch the satellites. And as I told, this is a repeat cycle of 12 days. Polarization, say single polarization, dual polarization, circular, quad pole, all type of polarization are there with the end resolution will be around 6 meter to by 6 meter. And overall swath, you see 240 kilometer resolution swath for all type of high resolution. And data will be free and open. So this technology, this slide I will just briefly how we get the high resolution as well as the large swath. In the left side, you see this is conventional synthetic aperture radar. You get the strip map. That means the strip map is a very around 50 or 100 kilometer swath you will be getting with the higher resolution. Or if you get the scan sort mode, then we have the different beams. Different beam will be taken and then they will be synthesized. So that way you get the coarser resolution, but your sigma naught or the accuracy will be not that good. So these are the earlier synthetic radar or present synthetic radar like our RSET or US04 I was talking about, that is also similar. But in this case, sweep SAR technology, you can see right inside the transmit is there on the full swath, that is around 240 kilometer, but you are getting from the different regions within the swath when you are receiving. So that way, all the received signals are processed individually, like normally synthetic radar we do with the full swath, but in this case, from individual beam, you are getting the received signal and then you integrating it by that technology, and that mainly because of one of the major reason is because you have very high 12-meter antenna. That is so through that you are getting this high resolution as well as the very large swath. So that means transmit time, if you see antenna is from the different regions, it is transmitting fully for all these 24 beams. But when we are receiving, then from each beam you are getting separately. So those are being used later on for the processing. Major objective of these are the, as I told earlier also, scientific point of view, I study the ice sheet and glacier for the climate change point of view, as well as the carbon point of view for the all forest agriculture, and then for the deformation. But in addition to this scientific understanding, we wanted to have some of the useful applications also, like for the dynamics of water, hydrocarbon, as well as from the wetland point of view, how they are changing. And then from India, as I told earlier, also we have the major application in agriculture. So how monitoring of the agriculture in every 12 days with the coarser, higher resolution as well as higher swath, we can have that. And one of the major application point of view of the hazard mitigation and urgent response. So these are some of the other applications. Overall plan, because this is the ISRO NASA system. So some science they have a earlier thought also, but in addition, when we jointly we are meeting regularly, so we also started from Indian point of view what science we can do in each domain. So ecosystem point of view, agriculture, biomass, and crop monitoring, which is one of the major thing. Forest biomass, soil moisture, high resolution soil moisture. That is some of the major science questions we wanted to answer through this. And from land deformation point of interseismic as well as post-seismic deformation, both, whether we can study using this and the landslides. Similarly, in the cryosphere from the polar regions, how the polar glaciers are changing, or the ice sheets are changing in the slow motion as well as the rapid motion. Both type of things also we wanted to study. So those all will be studied using this sensor. In addition to that, earlier it was not planned when NASA was thinking about the coastal and ocean point of view, but from India, because this is all three sides ocean. So we started that from the Indian point of view. These are some of the major things we will like coastal erosion, shoreline changes, subsidence in the coastal regions, and ocean surface wind. These type of studies also we were added from in our science plan, and now from the US side also, from their area also, they have added many such applications. And disaster, anyhow, flood is one of the major things which we'll be studying using this, and some of the other disaster like earthquake also getting. So these are major science applications, and all those things we can do using the, as I told, L band also or S band only, and the joint mode. So these will be done with the different modes. What we have decided on, more than 200 type of modes are available using this. After discussion, we have thought in different regions when we are doing the measurements. Then we'll handle dual, where we have dual polarization, somewhere single polarization, somewhere we have quad polarization. Depending upon the what type of applications are there, what type of regions are there, we'll be studying all those things with different modes. So all those things from the Indian point of view, these are the major things, modes, how we decided. One is the background land, that means the regular operations of the descending mode. We will be having regular operations in S band and L band. Then from agriculture and forest point of view, in the we will having almost every 12 days in the circular polarization as well as the quad polarization for the higher resolution point of some of the studies we want to do that we decided. And in the coastal and oceans, also a number of applications, as I earlier told, those modes will be there. An area has been all this area where the observations will be taken. That's why all this area have been shown different colors, because this will not be taking S band, as I told, will not taking all over the globe. S band data will be available only in this particular region near the India, as we decided, and some of the polar regions in the Antarctica as well as the Arctic region will be taken. So depending on the what mode, what time we want to take observation, after a lot of discussions and debates, these areas and modes have been decided from the observation point of view for initial first year, because every 6 months we will be again thinking that whether modes can be changed or requirement of change is there or not. Based on those discussions, we will be deciding whether any mode or things we can change or not. But initially we'll be having we decided that we'll having only these modes as well as these time wise also, as you see the operation calendar in this slide. From the whole year, at least first year, every 12 days, how the ascending mode, what type of observation will be taken and what type of area will be chosen. So for the cryosphere or for the Indian landmass, ocean point of view, or for deformation point of view, because some place you will do interferometry. For if you need interferometry, other observation you cannot do, other type of mode you cannot take, and that is very regularly required. So based on all those requirements from the different themes, we have discussed what type of observation should be there, what time of observation should be there. So this way whole observation plan has been made. And data, as I told, will be available to all users. Level different level data like other satellites. The level 0 we will be there, that is raw data. Level 1 is geotag, and level 2 is the georeference data will be provided. Not only this single polarization, but the polarimetric data also will be there, as well as the interferometric data will be provided, like covariance matrix and all those things will be available to the user. In addition to the normal data, higher level product like level 3 mosaics, as well as some of the science product what we will be developing from the India as well as the US side. Some are the separately and some are the jointly products are being developed in the each theme. So those products as the level 4 will be also be provided through our ISRO website, mostly through the Bunidhi from the National Remote Sensing Center, all this. And these are some of the science products what will be there from the ecosystem, as is a forest cover, forest disturbance map, or crop area, from cryosphere, the dry wet snow or glacial velocity. These are the things will be provided. And data will be downloaded at different places from the Indian stations as well as the other stations all over the globe, and will be downlinked these stations and will be provided to the users. Activity was post-launch activity. That means after launch, suppose it is launched in end of January, then after the 90 days commissioning phase will be there. Initially 90 days will be commissioning phase, where all the engineering and all other system operations will be done. Thereafter we will start the CalVal phase, the very important phase, the calibration validation of the data or instrumentation, that will be there. And when this is finished, this time that is within that calibration phase, we will having all over the globe data, science mode data will be there. And after this calibration, we will be starting all this calibrated data to the user for doing their science, as well as the later on the application of this data. So this is the presently overall how the data will be made available. And from the calibration, we are doing from the Indian point of view, pre-commissioning phase, what are the plans we have made, what are the systems we have put in the place, and then after commissioning phase, how they will be taking the data. All these plans have been made, and some of the instrumentation has also been placed like these are the calibration sites we have all over India. We have planned. Some are in the campaign mode. We will be doing for during the farewell phase all over India, and some of them will be the permanent sites will be there, and some of the place like in the Hyderabad, near Ahmedabad, Desalpar, as well as the Antarctic region. This instrumentation have been already put where we will be taking data, and for the experimental purpose, we are already calibrating with the other sensors what are presently available in the space. So these are being done. These are some of the science product what we have planned, which will be given to the user from the ecosystem, triosphère, solid earth, ocean point of view, which we think this will be available to the users, and what is the accuracies we are planning this data, that also we have decided presently. And then and not only the calibration of the system, but the validation of the science product also, what product we will be developing, that also has to be planned and validated first before providing to the user. So we have also made the plans where we having all these validation sites for the science data for different themes. So that will be there. These are some of the softwares what we had developed earlier. It's called the MIDAS, Micro Data Analysis System, which is working for this other sensors presently like RSS sensor, which has a polarimetry, interferometry, as well as the polarimetry, interferometry SAR. So similar software will be, or this software will be added for the NISR also, so that people can directly use data within this software and no other things are required. As such, other softwares are also available for this analysis of the synthetic picture data, but this software will also be there. And as I told, we had a airborne synthetic picture radar earlier also. That is where we had some same campaigns to test whether how the data, simulated data, will be available for the NISR. So prior to that, we had this campaign in India, few regions, and as well as in the US. And this data is also available. I'll show from this side. And these are some of the just examples of this in the US side for this data what we collected in the airborne, to show that how the L-band data will be there, how the combined data will be there, and you see the accuracy wise, if you have the L plus N band, then how good better accuracy you can get using the two bands as well as different polarization. Similarly, for the triosphère point of view, if you want surface feature, you can get from the S band, but somewhat deeper features, if you want to see crevice, then you can go to the L band, and jointly also many features we can get. So these are the just some examples using airborne data. And one of the last I will talking about just a few minutes on the because we only on ISRO or DOS we cannot use or not hold the data. But we want the other agencies or other researchers, academia also to be participate in the utilization of this data. So we have a launch utilization program, NISR utilization program, so that other people also can learn about the what is the SAR data is there, what is interferometry, what is the polarimetry. We'll giving trainings also, and also they will like them to participate who are the some expertise in this, to participate in this our utilization program. This will be the 3 to 4 years program is there, which has already been announced on our ISRO website, so that people can start using this data, and they can tell what type of data they want to use. Yeah, what type of study they want to do with the data, or what algorithm they can develop, which are not the usual algorithm, but something else if they want to do, or some extra science they want to do, if they want to suggest what this science I want to do, something not the usual, because usual things or the usual products will be provided from the ISRO side, normal products, but something extra they want to do, some new science, new applications. So those things they can suggest, or some good algorithms for the or improved algorithm. If they suggest that they can suggest in the utilization program, this program will be available. Already announced in July itself, and till October we will be having this asking for the proposals from different agencies, which proposals will be screened in. As I told, by October 31st, people can submit the proposals, and we will be screened critically all these proposals, and then based on this criteria we already made, proposals will be selected. Depending on how much funding we are having and how good are the proposals, either people can have their own institution or with jointly with the other institution that also can be planned, so that we can have good science proposals, application proposals, and good algorithms that people can provide, so that this program can we are planning with April 2024 this plan utilization program will be provided to all this who applies and whose proposals have been selected. So this is 3 years, as I told. Normally we are planning up to 2027, or maybe there are some proposals depending on the what type up to 2028. We can be this can be given to them, and this is a site from where we can get all the details about this program. And this is just how we are preparing for the NISR since you can see since 2013-14 we are having regularly, we are meeting together with the US agencies as well as the Indian, many collaborators are there who participated in our earlier programs. So regularly every year we are meeting with them, and this year also March 2023 we had a science meeting. If you saw someone interested, these are the resources from the NISR point of one very good handbook is there. So 3 years back, this was handbook was developed. This is available, soft copy is available on this site. In addition to other documents like utilization plan, all the reports, as well as some of the tools, as I told on the MIDAS, as well as ICE from the US side. These tools are there, and training modules from MIDAS, NOSDEC sites. We will be providing. These are the some website, main website from the ISRO side, where you can get all this whatever I was talking about this last 1 hour data, as well as the products. Like one is the meteorology oceanography MOSDEC site for the met ocean data, VIDAS site for some of the tools and some of the analysis tools are there, and one of the very good as well as the encompassing everything is site from Bhuvan from the NRSC is Geo platform, where you get the most of the data. Here itself you get the within this Bhunidhi talking about, where you get all the you will get all the remote sensing data from the Bhunin side of the Bhuvan, and not only the data but all of the services from the Bhuvan will be there. And NRC side and ISRS, where the National Information System for Climate and Environmental Sciences, where also you get the climate type of data from this ISRS. So these are the sites where you can visit and get much more information about that data, as well as the analysis tools and many other services. So overall, thank you very much for patiently listening. Thanks.
Thank you. Thank you, sir, for the excellent lecture. Now, if you have some of our panelists or the live members, if they have questions, we can take up. One question is there, but I think that is wrongly put up. There is a confusion with one of the students. He's confusing NISR L-band and Aditya L1. So yeah. I think that is some confusion. So he has asked the same question. S-band hybrid circular polarization. What are some benefits and possible applications?
Yeah, because some of the applications you can have from there. If you see the classification, I showed some of the classification examples for the cryosphere and this I think agriculture also. In a single or dual polarization, you cannot get this type of classification. You get only either horizontal or vertical. So many things, many type of even agriculture, the crops or forest type, you cannot classify. Or in the case of this cryosphere also, as I showed, different type of snow or ice. That classification you can do much better way with the polarimetric techniques, which you can't do with the dual polarization or single polarization.
Sir, during because we have been interacting with the student community, with the user community for quite number of years now. Some of them have asked during our interaction on the seismic deformation. So this is the recent one, like the stress is getting built up. So there is some threshold at which point the stress releases and the earthquake happens. So there was a question that can NISAR detect the buildup of the stress, and can it be accurate enough that we know that now stress buildup has been reached threshold level, earthquake can happen maybe 1 month, 2 month or something like that. So is it possible to detect the stress buildup?
This detection of stress is can be done because you can see the deformation, how the deformation is happening, how much is happening. But this telling that this will it will be blasting or maybe erupting, that is very difficult. When it will happen, that is not possible because you don't know, because many places you know the stress is there, but first thing is monitoring of this, how much it is stress is being developed. Changes you can do, but not when it is going to happen. That's not possible. Because many places are there. We know since many years it is there, but stress is there, but they are not. Earthquake is not happening. You know the places, the possible areas, you know, and for the locations only you can do.
Yes, sir.
Afterwards you can see, but if the earthquake happens, then how the deformation is happening, those things you can do.
Yes, sir. And one more question, because this is a 3-year science-based mission. So, because as we have the Sentinel, they have this continuity mission. So, what will be the follow-up of NISAR? Because once people start using this freely available interferometric data, 12 days, so they may be wanting to have more such kind of missions.
Yes, that but presently it is not being planned. Frankly speaking, it is not being thought about how it will going upon. We have to see first at least 1 year that how the good is that how it is totally new concept is there. As I told, it will be highly useful data will be there because interferometry very accurate interferometry will be there, polarimetry will be there. But from the point of view of the agencies, we have not thought the follow up on. As of now, follow up has not been planned. But maybe if we 1 year or see afterwards, we see that is a high potential, because financially also money is also involved from the both agency and manpower, everything, many things are involved, and cooperation. So that may happen, but presently it is not there.
Yes. And one question related to this is also question with reference to our interaction with the user community. So they like the accuracy of the altimeter, especially for inland hydrology. But their question is, can we increase the temporal resolution? And will there be follow-up of Saral Altica mission with the more constellation like of missions, with that apart from the SWOT, which has the 21-day repeat wide swath altimeter? So, is there any plan to have such missions from India or maybe jointly in future, so that we can have more temporal coverage over the inland areas?
Yes, presently it is. I will say from our side also, from scientific point of view also, we are very much behind that. This type such mission should be there. Altimeter, as I told, SWOT anyhow. Who are asked question, they know the SWOT is there, where a larger SWOT. We need many altimeters for this constellation. But altimeter is a mission which not only required the sensor, it required the ground also accuracy, as well as some of the stations like Doris we call it, or LRA, laser refractometry. Those stations are required, which we if available to us, we can have the altimeter. But for that, these are the commercial things are there. So we have to involve them, and then only we can altimeters can be there. So these are some issues with the altimeter. But yeah, we are talking in different agencies under cooperation, what we call the COS as well as CGMS. Different agencies are there where we talk about that agency-wise cooperation, that means mission-wise, and CGMS agency where users comes from the atmospheric ocean science users are there. So from those side, we are planning to have such teams or task team where we can justify these missions, and with cooperation we can have such missions.
Okay.
So those are there. But, yeah.
Yes, sir. Yes. Thank you, sir. And sir, there is one more question from Mr. Anoop. He's asking whether river algal bloom data can we can get this data, and also this paleo channels, whether it is possible to detect the paleo channels from the NISAR?
Yes, paleo channels may be there. Paleo channels are earlier also with the other sensors also have been tried. Paleo channels will be possible, but river data means blooms from the NISR will not. Bloom by the NISR, like also said, we have blooms we have seen. Such things will be there, but you need rivers. You need somewhat better spatial resolution. Presently, like ocean, we have 360 meters. That is the only problem.
And sir, one question from the student community. He's saying that we are not any government employed in government or some institute, but we have some idea of working with the NISAR. So, is there any chance that under the NISAR utilization program, some opportunities for students?
It is students, it is there. Yeah, that's why students of which type, I don't know which type of student is asking, but this is for academia only. This is what is this NISR utilization plan. Commitment should be there from this organization or institute I say. That the institute will work in student will see what type of students are there, because students should not happen that students leaving afterwards and who will do the work. If you give the work to some students or maybe then the institute also should be responsible that okay, this work will be done in certain time. Some maybe monitoring from their side also. We will anyhow we will be monitoring. So that way, like we do normally all these programs. So the institution backing should be there. Not an independent student will not. Should not.
So there was one more question of mapping the ionosphere using the L-band data, but I don't know.
No.
That is not
Mapping ionosphere is required for this L-band data. For the interferometry point of view, you require the ionosphere information. That presently is being using the models are being used. By that only is mapping. But getting ionosphere, that is also yes. If we have the different bandwidth, it can be done. That's what actually L-band we having. We are like 25 plus 5. So that 5 megahertz, that is for that purpose. If you have both, then we can do that some estimation for it.
Yes. So any our EC members or the other guests who have joined via the Teams, if you have any questions. Hello. Prakash sir.
Yeah, so I think if there are no further questions and any other comments by our EC members or the viewers, let us thank the speaker, and I would like to thank Dr. Rajkumar for giving a very comprehensive talk on the newer aspects of the work in the remote sensing field, as well as highlighting the importance of NISR mission, giving insight, put details about the instrument itself, the antenna system, how we are going to achieve the large SWAT using SweepSAR technologies, as well as the plan for data acquisition in different modes for both and L and S bands for different applications, and how different type of science applications are being planned, and what type of new information this NISR mission will be able to provide on various aspects of different ecosystems. So I'm sure that all our members must have got immensely benefited from this talk, and we all look forward for the NISR launch. And somebody was asking that the students, maybe some data from NISR mission also we would like to release for student community also. Once the data can come, they can also play with that data. That if some of you are not aware, still you can go to our Bhunidhi Vista portal. All ISRO satellite data, including RISAT 1A, SAR data is also full, visualization, full resolution visualizations are available. Some limited analytics can be done there itself. This is very useful, and a lot of students are already using these data sets. So I encourage that some of you keep on looking at our websites, and definitely we will enable some of the data set for the student community also. So with these words, I think let me thank once again Dr. Rajkumar for a very informative and comprehensive talk on this occasion of Remote Sensing Day. Thank you from my side. you have any formal vote of thanks, that also you can provide.
Thank you, Rajkumar ji, and also our President Dr. Prakash Johan ji, who has guided us in organizing this particular event, that is National Remote Sensing Day 2023. And I also thank all my EC members and all our respected members who have joined today. And we will make sure that final edited version will be posted in our website without any audio or the video problem, so that you can see the full presentation without any gap and learn more about the Indian Earth Observation Program with a focus on the NISA. So with this, I thank all the members and also our EC members who have joined together. And once again, many congratulations on the birth anniversary of Dr. Sarabhai and National Remote Sensing Day. And our activities of the chapters will continue, sir, this day and next week. Each chapter has organized many activities, so they will be celebrating National Remote Sensing Day. So thank you all.
Yeah, that already a lot of chapters are doing in Ahmedabad and other places.
Yes.
And I am hopeful that in Bangalore and other Delhi, etc., also some activity will happen. So thank you very much. And thank you, Thomas, and thank you, Meghaji, for joining this meeting.
Thank you so much.
Thank you, sir.
Bye.
Bye-bye. Thank you.